In this simulation, we're going to explore the concept of density. Density is defined as the amount of mass per unit volume, and we often express it in terms of gram per milliliter. In this experiment, we will determine the density of both an unknown liquid and a solid. To do that, we will use an analytical balance, some graduated cylinders, a beaker, a weighing boat, and some deionized water. To measure the density of a liquid, we'll need to measure both the mass and volume of the sample. Turn on the balance and select graduated cylinder number 2 to move it to the balance. Now, zero the balance by clicking Tare, and then you can remove the cylinder. At this point, you can add a liquid of unknown density to the graduated cylinder to make a measurement. To do that, click on the container of unknown liquid and fill the beaker on your benchtop. Then click on that beaker to dispense some of that liquid into the graduated cylinder. Using your up arrow key, fill the graduated cylinder to any desired volume and take note of it. Now place the graduated cylinder on the balance to measure the precise mass of that volume of liquid. Now you know both the mass and the volume of your liquid. You can determine the density since density is mass divided by volume. To determine the density of a solid, we'll need to be more creative in order to measure its volume. To measure its mass, however, let's start by placing a weighing boat on the balance and tearing its mass to 0. Then we can simply click on the container of unknown metal to place a sample of it directly on the weighing boat. Now we can record the mass of our unknown metal sample. To record its volume, we can submerge it in a liquid and measure the change in total volume of this liquid with and without the metal submerged. To do this, let's start by placing some deionized water in the first graduated cylinder by clicking on the deionized water bottle. The exact amount you add is less important than making sure you record the volume. Now add your metal sample to the graduated cylinder by clicking on it. Once the metal is put into the graduated cylinder, zoom in to record the new volume. You'll notice that the new volume is larger than the one you previously recorded. The difference between these two volumes is the volume of the metal sample. Now you know the volume of your metal, and with your previously recorded mass, you can calculate its density. Repeat this process of measuring the density of a liquid and/or solid sample as many times as you like.